now run our application server, we can see that our program is being compiled correctly. Now let's see what we have in the console. Here in the console, initially we were just printing the initial state of the application in these two logging statements. Let's now see what we have in these latest logging statements that we have here. So if we open here, for example, the state of the application, let's open the store data and messages, we can see that we have here a list of messages. Participants, we have participant 1 Alice, 2 Bob, 3 Chuck, etc. So now we are correctly processing this action, the load user threads action. So let's summarize what's going on here. If we go back to our smart component, which corresponds to this section of the page right here, what we have here is when the component is initially initialized, we are going to call the backend, we are going to call our REST API using this Angular service. This simply uses the HTTP module to send a request to the backend, and we can see the request here in the network tab. If we filter by API, the request will show up here and it's a hit to /API/threads. So we can see here that we are receiving from the backend a type all user data. So we are receiving the participants, the threads, and the messages for that user. Once we receive that from the backend, we are going to call the store and we are going to dispatch an action. So we are telling the store there is new data available from the backend and we are passing it in as the payload of this action. The store will then trigger its reducer function that we have configured here. So the store will take its current internal state, it will pass it in here as the first argument of the store reducer, it will pass in the action that it has just received, and it's going to take the output of the reducer function, and that will become the new state of our application. The store will then notify all parties of the application that have subscribed to the store. This way, each view of the application will be able to render the application state accordingly. So for example, the unread messages counter will be able to show the number of unread messages for the current user, Alice. The list of messages will be able to display the messages of the current thread. And the thread section will be able to display a list of threads. All these parts of the application are unaware of each other. They are only aware of a store, and the store simply emitted a new value. None of the parts of the application that need to render the data know what caused the arrival of that new value. Now, before going any further, let's start refactoring a little bit the store reducer. So, as we have seen, we have passed in here the initial state of the application as the second argument of provide store. Well, another way of doing this is to not specify any initial state, but instead, here in the store reducer function, what we can do is we can define a default argument for this state function argument. We can say that, for example, this argument should have a default value, which is the initial application state. Let's see if this is working. If we hit Ctrl S, our application will be restarted. And if we refresh our application, we can see that everything is still working as expected.